What's up everybody, I'm back, and right now I'm in the middle of like a big field, and other than this spotlight over here, it's pretty dark. You can see a lot of stuff in the sky. You guys can see Jupiter there, Saturn up there, and even though you can't really see it through my phone camera, I can definitely see the Milky Way very clearly. And yeah, but the big thing we're looking at today is this right here. It's a brand new telescope and it's an absolute monster. The model, it's called a C8, which means it has 8 inches of aperture compared to my last telescope, which had 90 millimeters. And a bigger aperture means that the opening in the front is a lot bigger. And that means that I could collect a lot more light and see dimmer things than the last telescope. As you can see here, it comes on a CGEM II mount. And this mount is probably the best part about this new telescope, because not only is it a lot bigger and beefier, which means if I bump into it or anything it won't move, it's also a tracking mount, which means that it rotates, this part here rotates relative to this part at the exact same rate that the Earth is spinning, which means that stuff won't drift through the eyepiece anymore when I take a picture of it. And that's nice, because if you're looking at a planet in high magnification or something, it won't drift out of your field of view. But more importantly, you can take long exposure shots through a camera. So right here I could take a 15-second shot with no problem on this mount. Yeah, and the only problem with that is it has to be plugged in, so I have this battery pack thing. But yeah, this is a monster setup. And if you're wondering what this is, it's a dew shield, which means that it kind of just it's just like a felt thing that goes around this, and it prevents the front plate on this thing from radiating its heat into the into space. And that means that dew won't get on the front, because the glass in the front stays warm, and that is important, because if there's dew on the telescope, it won't really work. So I know the title of this video says first light, which means that it's supposed to be my first time using it. It's not. This is my probably 4th time using it. Oh, look, there's a deer over there. It's kind of staring at me. Can you see that? Anyways, yeah, it's not my first time using this, but it is my first time attaching a camera to it, and it's my first time showing it to you guys, so I'm just gonna call it first light. And today we are going to look at Jupiter right there. And another good thing about this new mount is you don't have to actually move it manually. It has this little remote control, which makes things more quick and convenient, I guess. Look at that deer. Not sure if you guys can see it. There he is. Anyways, yeah, so you just go back, solar system, Jupiter, and it'll move by itself. And it's a little bit loud, but anyways, some of you guys may be bro, this takes all the fun out of stargazing. You can't move it by yourself. And that's kind of true, but the thing is, you can still move it by yourself just by using arrow keys, these big 4 ones. But if it's something like Jupiter, I don't really I'm not getting anything out of moving it myself, because obviously it's right there. So it kind of gives you the option to do it either way, and it's a lot faster this way. And this is really cool. So once it moves, I'll wait, I'm gonna turn off my phone flashlight. Yeah, so I didn't even touch the telescope and it went straight to Jupiter, which is just awesome. I believe that right there is one of its moons. It's not right in the middle, because the mount's not perfect, but we have those arrow keys, of course, to fix that up. And yeah, obviously it's a little bit overexposed. I mean, a 15-second exposure for Jupiter just doesn't make sense. It should be 1/500th of a second or something like that. So yeah, I'll change that. But yeah. Another thing that I forgot to mention about the telescope is that it has a much higher focal length, which means it has a higher natural magnification if I just hook up the camera to it. So yeah, if I had a 10mm eyepiece in my last telescope, it would be around 100 magnification, 91 times to be exact, and in this that would be 200 times magnification. So yeah, it's just a lot higher, which is, it's really nice if you have a camera and you're trying to take pictures of the planet. It could be a little bit inconvenient if you're trying to look at something really big like the Andromeda Galaxy, but that's not our problem right now. Right now we are looking at Jupiter right here. So yeah, I'm going to adjust those settings and show you the next step. Okay, so I fixed up those camera settings, and right away you can already see 2 cloud bands on Jupiter, which is absolutely crazy. I know I never did Jupiter before on the channel, but through the last telescope that I had, I did take photos of Jupiter, and like this kind of view that we're just seeing in the live view is the kind of thing I'd get if I like stacked 50 photos in Lynkeos or something and like put a ton of work into it. But through this monster of a telescope, you just see it through the live view. So that is very impressive. And you will also notice that it's not moving. Like through my last telescope, Jupiter probably would have moved in and out of this frame in like 10 seconds, but this mount is currently counteracting the Earth's rotation like exactly. So as a result, Jupiter is standing perfectly still. And that actually changes up our process a little bit. Instead of taking a bunch of pictures of Jupiter, we're going to take a video. And the reason we do that is so that instead of taking maybe 50 photos, if we take a 60 frame per second video and we take it for like a minute, we'll have what, 3,600 photos of Jupiter. And stacking 3,600 photos is like gonna get you like some really, really good results. And yeah, that's what people actually usually do. Taking the photos like manually is kind of rare. So this definitely should give us better results. So yeah, I'm just gonna hit the record button on this and we'll take I was thinking a 2-minute video of Jupiter just because, you know, the more the merrier, it won't hurt. And yeah. All right, so we just finished taking all the photos of Jupiter, and yeah, this telescope, it even looks like a monster. I love it. And yeah, also I kind of did gloss over a lot of things about this telescope, especially setting it up. It's not like you can't just plop it down here and then you know, expect it to point to Jupiter when I put in Jupiter. You have to first you have to kind of rough polar align it, then you have to kind of tell the mount where it's looking by telling it, okay, I'm gonna center the telescope on Vega up there. And then I'd do that for like 6 stars, and then it would kind of know better where it is, and then you could start putting stuff in. But then you have to do like a more accurate polar line and a bunch of other stuff. Yeah, in a future video I might kind of go over all of that kind of stuff just in case you guys are interested. But this one I'm kind of just like giving you an overview of the new telescope and just see what it could do on Jupiter. So yeah, I also have this wagon over here, which is pretty cool. This wagon is what I use to move each part of this telescope to the car over there manually, because this whole thing together is like 100 pounds. It's over 100 pounds actually. So no way I could just lift this and move it to the car. That's one disadvantage of having such like a monster here, but it's definitely worth the effort that it takes. So yeah, I'll see you guys tomorrow inside, and we will edit or process these Jupiter shots and see what we get. All right, see ya. All right, so here is our camera SD card, and this is the video right here. I can't open it on Mac, but it definitely is a video, and I could still run it through Lynkeos, which is good. I kind of like pre-processed it. I cropped it so that kind of only Jupiter is in the frame, and that would just make everything faster because, you know, there's fewer pixels in the image. So I'm just gonna load that in there. And I think eventually I'm gonna kind of move on from Lynkeos to other programs called, they're like Windows only programs. I had to get a Windows computer for school anyways, so I'll be able to run those computers or those programs now. One is called Auto Stacker, and that's to like stack the pictures, and then the other one is called Registax, and that one's to kind of like sharpen the pictures and denoise them. And Lynkeos kind of does both of those things in one program, and it's available on Mac, but it's just not quite as good as the other ones. But honestly, for this picture, it's probably not going to make too much of a difference because the scene conditions weren't like perfect, and I also didn't focus the telescope super carefully or anything. I was kind of more like a test run, but yeah, it should be fine for now. So I'm just gonna wait until this loads in. Oh, okay, there it goes. And I'll show you what an individual frame looks like that. They all look pretty similar. I mean, it's a video, so the frames aren't gonna look too different. But in each one, you could definitely see those 2 cloud bands, and maybe you could see the dark region on the bottom a little bit, but I'm not completely sure if we can see that. Anyways, let's make our box around, oh wait, no, I have to go to a line. Then we make our box around Jupiter and then hit a line. And if you were seeing my previous videos, you would have noticed that I usually had to go into Photoshop and like manually line them up pretty well, and then this would kind of like perfect it. But since the mount on the telescope can follow Jupiter throughout the sky, it doesn't really move too much between the frames anyways. Like, you can see how similar it looks in all of these. So we don't really have to do that. It's almost like the telescope did that automatically for us, which is super nice, because that means that instead of only being able to stack like 20 pictures, we can stack way more. I think there's 1,920 individual pictures in this video. And yeah, the more pictures, the better for, you know, stacking. Just makes it more fine and detailed and whatever. So yeah, we'll go to analyze and do the same thing, put a box around it. And what this does is it kind of like gives a quality value to each of the pictures, and then we could like filter out the bad ones. So I think 1920, we'll just keep, let's say, around 75% of them, so around 1500. So let's just move this slider until we have 1500 images. That's good enough. There you go. Okay, and now we'll hit stack, draw our box. Let's go double size, because you know, it won't hurt. I'm not sure if it'll make too much of a difference, like I said, because these pictures weren't the highest quality, but yeah, this stacking process is a lot faster than the alignment process. You can see how fast that scroll bar is moving. So in a second, it will be done. There we go. All right, so here's our stacked picture. I'll zoom out a little bit, and you can see it's a lot clearer than the individual pictures. Like, now we can really clearly see that that kind of like darker region. I believe this is the bottom and this is the top of Jupiter, just because I know it has like a dark belt in the bottom. And honestly, our picture, when we like do our editing stuff, probably isn't gonna get that much better than this. Again, because, you know, seeing and focusing and all that, I kind of did it fast because it was my first like attempt on this, and I don't really know how to use the telescope completely. But anyways, deconvolution. I don't really know how to use these programs exactly. I'm gonna like do more research into that now that I have like a better telescope. But yeah, I'm just gonna play around with these sliders until we hopefully get, oh my gosh, it's blue. Did I mess it up? Okay, guys, I don't know why it turned blue. Oh, there we go. All right, it's back. Yeah, like I said, I don't really know how to use these programs exactly. But when I switch over to like Registax and Auto Stacker, I'm gonna look into it more so we can get a more perfectionist image, I guess. I'll move this over a little bit and it changed color again. All right, guys, I had a little bit of difficulty using Lynkeos. As you saw, Jupiter turned blue. So after redoing it a few times and, you know, perfecting it, I ended up with this picture right here. And I'd say this is honestly pretty good. It's not that different from like our stacked picture, and it's definitely not as good as the telescope could do, but you know, the limitations of this picture aren't really with the telescope. It's more with me not knowing exactly how to use the telescope, and also like, I don't know, the atmosphere being turbulent and, you know, haziness and stuff like that. I could show you the best picture of Jupiter I had on the last telescope right here. And if you put them side by side, this one is like grainier and stuff, but I'd say it's probably more detailed. Like, you can see a dark region on the top, the bottom. You can see the great red spot there a little bit. I'm not really sure what that would have looked like here, but it's kind of like similar in quality. And honestly, this one I'd put a lot more effort into, and I kind of knew how to use the telescope better. So I have some pretty good feelings about what this telescope is going to be able to do once I get better at using it. So yeah, here's our picture of Jupiter, and I hope you guys enjoyed taking a first look at this telescope. And yeah, I'll take you guys out with me as I get better and better at using it, and hopefully our pictures also get better with our skill improvements. And yeah, I'll see you guys next time, and thanks for watching.